Hello, everyone. This is Mr. Burke here, and welcome to the lesson for Chapter 6. I did look at the syllabus, and the good news is that the lesson for Chapter 6 is going to be broken up over 2 weeks. So I think that'll be good to allow us to kind of lay a good foundation for understanding of a normal distribution, where we'll have an opportunity to then tackle and incorporate more effectively the central limit theorem in our work next week. So we're going to be spending the next 2 weeks on Chapter 6. And you'll find the notes I have available online today. I'm not going to do the normal homework questions like I do, where I do it directly from my math lab. The questions come from the homework anyway, and I'm going to be using here. So I'm going to be doing them directly in the notes, and then we'll be using StackCrunch to calculate things. So we're not going to be able to import like sets of data that we're going to have to do easily there. We're going to have to input everything in the StackCrunch. So we're going to handle it that way. So I'm going to be going back and forth between my document camera and StackCrunch for the purpose of the lesson today. Let's see if I can get in here. I wasn't there a second ago. Yeah, I think I'm in here now. All right, let me go ahead and start sharing what's on my document camera. So you'll see I have some notes here. I already pre-filled these out, so I'm going to waste time copying this out. So this definition comes from your book, and very simply it states that if a continuous random variable has a distribution with a graph that is symmetrical and bell-shaped, that should be a comma, then it is a normal distribution. There are a few different types of normal distributions. For section 6.1, we're going to be studying the standard normal distribution. And the standard normal distribution has a few characteristics, and we see these down here. So first off, like any other normal distribution, it is bell-shaped. That's going to be true of all normal distributions, whether they are standard or just regular normal distributions. But the other trait, though, is that in a standard normal distribution, notice that standard is underlined. The mu, that is the population mean, is going to be considered equal to 0, and then the population standard deviation is equal to 1. What is important about this is there's no real practical application for the standard normal distribution per se. But what this is effective at generating, like these two properties in particular, this is effective for generating what we know as z-scores, which you'll recall that we studied a little bit in chapter 3, but we're going to be looking more extensively at them today in this lesson here. You'll also note below here that I have the directions for StackCrunch, and there's another definition that I wanted to incorporate in here. And let me box this little piece down here. And that's going to be for a standard normal distribution. That's SND. So I didn't want to write standard normal distribution because I knew I was going to be limited on space here. So for a standard normal distribution, a critical value is a z-score on the border line separating the z-scores that are significantly low or significantly high. Excuse me 1 minute. Oh, excuse me. And we're going to look at a notation where we're going to have z, and then we're going to have this this alpha. This alpha, that's a lowercase alpha, that's a Greek letter. That's going to stand for the level of significance. Is going to represent the area to the right in a graph. There's a few characteristics I also wanted to point out about a normal distribution. So I'm going to go to the top paper for this. Now, if you didn't get this down, just go ahead and pause us, and then we'll come back here. Come back. You can copy this down and then join me for this here. In a normal distribution, we find that the area under a normal distribution is equal to 1. So the whole area under the normal distribution is equal to 1. And we notice here that this is it's curved and bell-shaped and it's symmetric, okay? And we notice here that the mean is in the middle here, which means that if the mean is in the middle and this is symmetric, the area of this portion is going to be 0.5 and the area of this portion is going to be 0.5. You know, basically 50% of the area separated on each side of the mean. You'll also note here that with a standard normal distribution, we use this to put together the concept of z-scores. And then that concept of z-scores can be generalized to any normal distribution, whether it is standard or it is not standard. That's what the formula will take a look at in a little bit. But this part's going to be important here. So one thing to consider, and again, we looked at this in chapter 3 a little bit, but we're going to look at this in more detail now, is that in the center, in the mean, we have a z-score of 0. So if you have a value that's below the mean, then its z-score is going to be negative. If you have any value that's above the mean, its z-score is going to be positive. So let's go ahead and take a look at some examples of what we're talking about here and see what kind of problems we are asked to do. Oh, one other thing that's really critical in working with normal distributions. We talked about the area under each of these normal distributions. Talk about the area of the total being equal to 1, okay? But in this here, working with normal distributions, we want to associate area being the same idea as probability. Okay, so let's see what each of these questions is asking now. It says here, in exercises 9 through 12, find the area of the shaded region. Okay, the graph depicts the standard normal distribution of bone density scores with a mean of 0 and a standard deviation of 1. Now, I mean, in truth, I doubt that you could have like a negative bone density. That would be kind of impossible. But, you know, they're just kind of trying to apply something to it. But we'll get to the applications in a little bit here. So when we talk about associating this with probability, let's see how we can write probability statements with this. Now, they're not asking this yet, but they're going to in section 1.2. Okay. What they're saying in this problem here is we're looking for the area to the left of 0.44 for the z-score. Okay. So for question number 9, what it's really asking for, it's asking for the probability that we obtain a z-score that's going to be less than 0.44. That's what probability is being sought here. So I'm going to generate the probability statements for each of these, and then we're going to explore how each of these are done in StatCrunch. Okay, question 10. In this problem, we have a z-score of negative 1.04, which is to the left of the mean, so that sounds about right. It should be negative something. But you notice that the area to the right is shaded. So what they want here in finding this area is we want to know the probability that the z-score is going to be greater than negative 1.04. Okay, and that's going to be a probability here. Let's take a look now at number 11. Here we notice that we have a shaded region between negative 0.84 and 1.28. So what we're looking for in question 11 is the probability that negative 0.84 is less than z, and that z is going to be less than 1.28. And that's going to generate some probability. Now, I'm going to do this for this last one here. But what I'm going to encourage you to do is, if you want to, pause the video and see if you can come up with the correct answer to this here. Okay, so if you want to pause the video, you can. Otherwise, I'm just going to keep going. Okay. For number 12, pause if you want to try this first. I want to know the probability that negative 1.07 is less than z, and z is less than 0.67. So if you pause the video, you came up with that, you did that well. Let's go ahead and take a look at how we do these 4 things in StatCrunch. So hopefully you have this information down. And we're going to go ahead and look in StatCrunch to see how we put this together. Now, remember, when we're looking at a standard normal distribution, what makes it standard is that the mean is 0 and the standard deviation is equal to 1. So let's go ahead and do a new share. We're going to go to StatCrunch now. Let's here. All right, so here we go. So I'm going to go to stat now. I'm going to go to Z stats. Hold on. Calculator. Yeah, this is going to be calculator and then normal. So it's going to be stat, calculator, normal. Remember that your directions are going to be included on the front of the first page toward the bottom left side. So stat, calculator, normal. And notice here it gives me a picture of a normal distribution. By default, the mean and standard deviation in that picture is going to be 0 and 1. So we don't have to change a whole lot of this. Now, one thing that we cannot change, we can't change the fact that an X is there. And that's okay. So long as the mean is 0 and the standard deviation 1, we're going to treat that X like a Z by making the mean 0 and the standard deviation 1. And the first question wants the probability that Z is less than 0.44. Now it has less than or equal to, not a big concern. All right, but the proper notation is to make it less than that. So we want the probability that X is less than or equal to 0.44. We're going to hit compute. And notice here, it gives you a picture very similar to what is in the book. And furthermore, what's more important, it gives you a probability, which is located to the right here. And it gives you, we're going to put this to 4 decimal places. So this is going to be 0.6700. So that probability is going to be 0.6700. And I'm going to write that on the paper. Next, we want the probability that Z is going to be greater than negative 1.04. So first thing I'm going to do is I'm going to switch this probability around to greater than, and then I'm going to type in -1. All right, and here I'm going to hit compute. And again, we get a picture very similar to what's in the book, and it calculates the probability of that being 8.8508. All right, now the next two probabilities you'll notice have shaded regions that are in between two Z-scores. The way we handle questions 12, 11, and 12 is we're going to click between. And what that's going to let us do is going to let it put it between two values. We're not going to change the mean or the standard deviation, but we are going to put those two Z-scores here. That's going to be -0.84. And this will be 1.28. And we're going to get an area of 0.6. It's going to say 0.69927. So the area is going to be 0.6993. And that means is if we were to just select some random Z-score based on this distribution, what's the probability that the Z-score would be between -0.84 and 1.28? And that would be like about 70%. Okay. Question 12 says, what's the probability that the random Z-score is going to be between -1.07 and +0.67? So 1.07 and +0.67. I'm just going to turn around and make sure that's right. Yeah, it looks good. And there again is we get another picture. It looks very similar to that. And we should notice that the probability is going to be 0.6063. Okay, so 0.6063. And let me just show you exactly what I have on my paper before we come. And then we're going to take a look at a few of the problems on the next page here. So let's do new share back to paper. And you see that I have the answers to the probabilities we calculated. Okay, so let's go and look at this now. In this question, what it's providing us with is the area or the probability. And then what it wants is the corresponding Z-score as a result of that. Now, the old-fashioned way is to use a table to do this, but that can be a pretty cumbersome process sometimes. But we can go ahead and use StatCrunch for this. Now, we're not calculating a probability. We know the area already. But in 13 and 14, we want to know the corresponding Z-score, and where they are. So we'll notice that in these two particular questions, we have pictures where the areas are going to be to the left, which it means that we're going to be using the less than symbol on this one. So let's go ahead and go back to StatCrunch and let's see how we find the Z-score for this then. Hang on, I'm going to put Z. And Z is going to be rounded to 2 decimal places. All right. So now we're going to go back down here. We're going to clear this out. And because we only have one side shaded, we're going to go with standard. So we're going to go with X is less than. We're going to clear that out. and then we're going to put in the corresponding area. Once we put in the area, it's going to give us the corresponding z-score needed. So because the area is shaded to the left, I choose the less than symbol, and the area in question 13 is going to be 0.8907. And when I put that in, you're going to notice I get a z-score of 1.23. So my z-score in question 13 is going to be 1.23. Please bear in mind that z-scores are typically rounded to 2 decimal places unless otherwise requested. In your notes for question 14, it gives an area that is equal to 0.3050. So, and it's to the left again, so I'm going to leave that pointing to the left. So that's going to be 0.3050. Oh, no, not there. Hang on. Sorry about that. 0.3050. It's going to go there because that's the area. And that's going to give you the corresponding z-score for this now. And you'll see it gives you a picture just like you have in the book. And that corresponding z-score is going to be negative 0.51. And that's going to be the answer to question 14. Now, we will, in fact, be doing other questions where we're going to have some shading to the right, but we'll see what those all look like as we go through other problems here. All right. Oops, hold on. New share. I'm going to try this again. This is what I want to see. Okay. So now I have the corresponding z-score. So the z-score here is going to be equal to 1.23. And then the z-score here is going to correspond to negative 0.51. All right. So we're going to take a look at some other problems that don't necessarily have pictures, but one of the things that you'll see will be attached to your notes for you to use if you want to use them and print with us is going to be some normal distribution curves, which I hope you'll find to be very handy, okay, as we look at these problems and then utilize these. Okay, so let's take a look at these problems here. Notice that in these particular problems, they give us the z-scores, so we're asked to find the area. So what I'm going to do is I'm just going to pick like 4 of these and just kind of put them together quickly and see if we can draw a picture of them and draw them properly, because usually you're not going to get a problem like this. Usually you're going to get something verbal, and then you have to be able to make a picture out of this, or at least put this problem correctly into StatCrunch. So I'm going to pick, let's say for this one, I'm going to pick number 17. And that's going to say that we want to know the probability that the z-score is going to be less than negative 1.23. Now, remember here, you probably want to put 0 here, put 0 in the center. Put 0 in the center when you can, so that when you're trying to figure out a z-score and approximate where that is, you were trying to find negative 1.23. Here's negative 1. So negative 1.23 is probably going to be about here, something like that. Okay. And then if you want the probability that's going to be less than that, that means that that less is going to be on the left-hand side. So this is the area that we're looking for. So in 17, what are we looking for? We're looking for the probability that z, and we're going to label this with a z down here for now, because we're looking at a standard normal distribution. The probability that z is going to be less than negative 1.23. That is going to have an answer. Okay, so we're just going to focus on drawing each of these kind of problems out, and then we'll put these in StatCrunch again and go ahead and calculate these. Question 22. Let's say we want the probability that the z-score is going to be greater than 0.18. So now, if you don't estimate everything perfectly, if you don't estimate what 0.18 is, not a huge deal, as long as you have but drawing the picture before you look at it in StatCrunch is good practice. So I know, again, 0 is here. Here's 1. 0.18 is like 18 cents on the dollar. So this is nothing. This is $1. 0.8 is probably going to be right around here. And I want to know when it's greater than $1, greater than 0.18. So that means when it's going to be greater than, I'm going to shade to the right. So it's going to look like this. So for 22, I want the probability that z is going to be greater than 0.18. Okay. Now, drawing these pictures is going to be very helpful for what we're going to do later. So please make sure that you are doing this, okay? Next, we're going to take a look at, bring up the graphs a little bit here, and we'll look at questions 25 and 26. And I want the probability that the z-score is going to be between 2 and 3. Okay, so I'm looking at the probability that 2.00 is less than z, which is less than 3.00. And this is where I have the graph paper is really nice. By the way, it looks like on these graphs here that these are touching. Officially, they never really touch. They come very close to touching, but they never really touch, okay? So that's a probability of the z-score being between 2 and 3, because this would be 1, 2, 3, okay? And then question 26, this is going to be between 1.5 and 2.5. So it's 26. We want the probability that the z-score is going to be between 1.50, which is less than z, which is less than 2.50. All right, so here's 1, here's 2, here's 3. So it looks like we're going to be between here and between here. Looking at these, so we anticipate that both of those areas should be pretty small. So, and again, I should probably mention this earlier, but that's okay. We'll get more practice with this. Do try and draw these pictures on your own so that you get some idea of what this all looks like. Let's go ahead and put these in StatCrunch again to see if we can find the areas, and we'll put those answers on that sheet then. Let's do new share. All right, so let's go ahead. Yeah, let's actually let's edit this. Why not? Won't let me edit. That's okay. Oh no, I could have just changed it where it was. So let me. All right, so static calculator normal. It's still going to be mean of 0, standard deviation 1. The first one is going to be x is, now I say x because of what's here. It's going to be less than negative 1.23. I compute, and my final answer for that's going to be 0.1093. The next one is what z is going to be greater than 0.18. So they're going to x is greater than 0.18. Take compute. My answer that's going to be 4.42857. So 0.4286. And the other one's in between us, so we're going to click on between. And then we're going to put the lower and upper z-scores. I'm just going to put 2 here, and I'm going to put 3 here. I don't need to put the decimal. Oops, not 2 and 2, that'd be 0. So 2 and 3 here. And look, we get an area of 0.0214. And then the other one's going to be 1.5. It's going to be 2.5. Should be a little bigger, not much though. That'd be 0.06059. So this would be 0.0606. Okay, let me go back and show you my paper now. And you'll see all the corresponding probabilities are located there. I'm gonna split this up into 2 videos this evening. So you can kind of look at one video at a time. Let's see here. Let's go out and take a look at what's being asked here. Just a little bit of a different type of application problem. So we're looking at this here. It says find P99 in this question, the 99th percentile. This is the bone density score separating the bottom 99% from the top 1%. So if they want the 99th percentile and they're separating the bottom 99 from the top 1, what we're going to do is we're going to try to approximate where this is going to be on the graph. And I'm going to put this over here. So what we're kind of saying is that this area here is going to be 0.99. And that's going to give us a z-score here. I'm wondering what that z-score is. Okay. So they're giving us the area by saying this is the 99th percentile, but we have to find what the z-score is. Now notice that this area is to the left. So when we put this into StatCrunch, we're going to have this pointing to the left. But we're going to get to another example. So this is the 37. So, and then we'll see an example where we shade on the right and then work with StatCrunch using that. Okay, so let's, actually, let's go ahead and draw that picture out now. Why not? So, in fact, we're going to even do, we'll do 39 also. So you get a picture of all the 3 different types of problems. P10 says the 10th percentile. This is the bone density separating the bottom 10 from the top 90%. Yeah, okay. So it wants the 10th percentile. So maybe the 10th percentile is going to be about here. So maybe the area is going to be here, 0.10. So this is still going to be shaded to the left, which is, by the way, the normal practice, but sometimes they do shade palms to the left too, to the right also. This is 38. And then here we're going to look for the z-score also. Now here we should expect the z-score to be fairly high. It could be over, it could be pretty close to 3, if I'm not mistaken. Probably 2 point something. Here we should expect the z-score is going to be pretty low, okay? Because we're only like dealing with 10% of the area here. But let's take a look at 39. It says the bone density scores in the bottom 2 and the top 2% are used as cutoff points for levels that are too low or too high. Find the 2 readings that are cutoff values, okay? So what we're looking at here is we're looking for this area where this is 0.02, and that's going to yield a z-score. And then we're looking at this area here to the right. So here's what an area to the right finally, and that's going to give us a z-score. So we're going to see what that's going to be. This area is going to be 0.02. So we want to separate the bottom 2% and the top 2%. So this is going to be 39. Okay, so instead of drawing the z-score and then finding the area, this time we're given the area, now we're going to find the corresponding z-scores, just kind of doing the process backwards. So for each of those questions, I'm going to go ahead and find the corresponding z-score in the problem. And let's go ahead and do this. Okay, so for this one, the mean is still 0, the standard deviation is 1. Okay, we're going to go with the standard one for the first two because there's only one side that's being shaded. Okay, actually, we'll probably use this for all 4. And what we're looking at here is we're looking at the left side in question 37. We're looking at the left side being shaded. What area is being shaded? 99%. So when we press that, that gives us a corresponding z-score. And that's going to work out to be 2.33. Oops, wrong one. Yeah, I just put the answer for that on the wrong graph on my paper here. So if you have 99% of the area and that z-score is to the left of where z is equal to 2.33, if you round that properly, okay? The next one, we have the 10th percentile. So instead of 0.99, we're going to just use 0.10. So this is for question 38, and I put that in. I hit compute. Notice we get a z-score of negative 1.28. And now we've got a corresponding z-score there. Okay. Now here, this is where this is really beautiful. Taking a look at 39, okay? Let me just type in 0.02 because we're looking for the bottom 2%. And you notice here, for this one, we get the bottom 2% of the graph shaded, and that gives us a corresponding z-score of a negative 2.05. So I'm going to put that on my graph here, which we'll come back to and look at in a moment. But now, let's say I want the other side shaded. I want the top, like 2%, and I want that corresponding z-score. All I do is just switch the inequality. Oops. Oh, I take that back. I need a 0.02 here, but I still have to switch the inequality, and now that's going to give me the top 2%, and that's going to give me a z-score of positive 2.05. Now, if you're looking at your paper and you notice, let me come back to the paper on this here. If you notice that these numbers are going to be the same, like identical, except this one's negative, this one's positive, that would make sense because we're dealing with 2% of the area here and 2% of the area here. And remember, normal distributions are symmetrical. So that would always work out that way, that if you have the same percentage on each end of these two tails of the normal distribution curve, that the z-scores that would be yielded should be the same values here, except one's going to be negative when it's below the mean, and the other one's going to be positive when it's above the mean. So hopefully that's going to be helpful to you guys there. We'll take a look at the last couple questions before we, before we're done with this video. And it says exercises 41 through 44, find the indicated critical value. Round your results to 2 decimal places. So now remember, this is the definition we received in the bottom right corner of page 1. And I talked about the idea couple things on it. We'll talk about critical values. Okay. It's z-score on the borderline separating the z-scores that are significantly low or significantly high. And this alpha value is going to represent an area to the right. So this is kind of a statistical shorthand. So we're going to take a look at these 4 problems and then see how this is done. And then use, actually we'll just look at 2. I think it's going to be plenty to kind of illustrate the thing. So we'll look at 2 and then we'll call this video a wrap. Hold on. So let's say, for example, I want to find the critical value of z to the 0.10. So here's going to be 41. So z to the 0.10 is, I'm going to have like about 10% of the area here. The area is equal to 0.10, and I want to find the corresponding z-score for that. And then let's go ahead and take a look at 43. And I'm given, this is going to be z to the 0.10. This is going to be z to 0.04. So that means I'm going to go further this way, where the area here is going to be 0.04. And I want to find the z-score for this. So notice here, these are 2 kinds of examples where we have the area being shaded to the right. Okay. So we're going to go ahead and take a look at what these z-scores are going to be. For each of these 2, I'll record them. We'll come back and take a look. And that will make our first video. So share. Okay, so just now because we have the right side shaded, we're gonna, oops, yeah, that's right. We're gonna leave that pointed to the right. I'm gonna go ahead and what I want to do is I want to put the area that I have there for question 41. That's gonna be 0.10. I'm gonna hit compute, and that's gonna give us a z-score of 1.28. And then for the last problem, we're gonna put a z-score of 0.04 in. So I'm going to go ahead and just change this to 0.04. Notice here, as soon as I start putting something in, it's going to clean this out. And now I get a z-score of 1.75. And those are, for these particular problems, going to represent critical values. Now, critical values is something we're going to study a great deal more of, particularly once we start getting into chapter 7s, and especially 8 is going to be really important. With how we're going to do confidence intervals in chapter 7, it's not going to be so important, but is going to be more important for the work we do in chapter 8. So let me just show you the graph I have with the answers here. Okay, so I have the corresponding z-scores there that match here. So this will be 1.28, and this corresponding z-score here is going to be 1.75. Notice here that as the area gets smaller, the z-score, like this area is from here to here gets smaller, the z-score from here to here gets larger. Okay, because it's further away from the mean. The smaller the area, the further the z-score is going to be away from the mean. But yeah, that's should be probably a little closer this way. See, I have this like over 2, so I actually have this like kind of wrong. I probably have this back a little bit. So, but that's how you learn. You kind of guess where it is, and you're right or you're not, which more often, especially in the beginning, you're going to be wrong. So I hope you find this video on section 6.1 to be helpful. I encourage you to watch this a few times, try some of the other examples that are here on your own, okay? Use the graph paper if you find this graph paper to be helpful, and I will be creating the video for 6.2 coming right up.